Assalamu alaikum, sir. We are excited to present our project, the Line Follower Robot. We would like to thank our course teacher, Mr. Muhammad Abu Rayan, for their guidance and support throughout this project. Our team consists of 5 members, myself, Munawer, Munna. The last 4 digits of my ID is 1047. The other team members are Muhammad Tasnim Ahmed, MD Sheikh, Sifatuzzaman Mia, and Fahim Hasan. So this is the table of contents of our presentation. So let's talk about the introduction. What is a line follower? A line follower is an autonomous robot designed to detect and follow a path, usually a black line on a white surface. It uses sensors to recognize the line and adjusts its movement to stay on track. What is the need to build a line follower? We chose to build this robot to apply our understanding and circuit design, programming, and hardware integration. Line follower robots are not just educational but also practical, as they are widely used in industries for automated tasks like material transport. This project helped us enhance both our technical skills and teamwork abilities. My contribution to the project was assembling the robot, which included the mechanical and electronical components such as Arduino motor driver, sensors, chassis, battery, and nylon caster. I was responsible for ensuring that all parts are securely mounted and properly connected to ensure smooth operation of the robot. Thank you. Now I would like to invite Sifatuzzaman Mia to continue this presentation.
Assalamu alaikum, sir. This is Sifatuzzaman Mia, and the last 4 digit of my ID is 1360. Today, I'll present the features and methodology of our line follower robot. Now, I'll explain its key features and the method we uses to make it a reality. Let's start with the robot feature. So, first one is line detection. The robot uses sensor to detect and follow the line on the surface. The second is line type adaptability. It can follow both straight and curved lines without any trouble. And third is surface adaptability. The robot works on different surfaces like smooth or slightly rough floor. And fourth is direct control. It can adjust its direction quickly to stay on the line. And the others is autonomous navigation and programmability. Programmability means the robot behavior can be changed by modifying its program. Now I will discuss about methodology. Methodology. uh, First one is component selection. The right components such as IR sensor for line detection, DC motors for movement, and a microcontroller like Arduino Uno for decision making are carefully chosen to ensure the robot works efficiently. Second one is circuit design and integration, creating the electronic circuit and connecting all components properly. Line detecting algorithm. A program or algorithm is written to analyze the input from the sensor. This algorithm detects the position of the line and sends signals to the motors to adjust the robot's detection. Motor control and speed resolution. Controlling motor movements and adjusting its speed to stay on the path. And the last is prototyping and testing. Building the robot model and testing it to ensure it works correctly. So this all my parts, and finally I would like to share my contribution to this project, which was focused on testing and debugging. I ensured both the hardware and software work together seamlessly, and testing the robot's movements on a predefined track to identify issues, debugging sensor accuracy by calibrating IR sensor for different track colors and conditions, fine-tuning motor's speed and movement to avoid jerky or imprecise motion. And last one is ensuring the code and hardware interact seamlessly and modifying other components as required. So now I would like to our next member to continue this presentation. Thank you.
Thank you, Sifat. Now I will talk about the equipment or components that we actually use in our ultimate RoboPilot. So first component is Arduino Uno. This is actually our major component. The Arduino Uno is a microcontroller based on a board 80 mega 328P. It has total 14 pins, 6 for power output and 6 for input, and a USB connection for the programming. The board can be operated at 5 volt and can be through the power outage like or external supply like 7 to 12 volt. And it has a feature for 16 megahertz crystal oscillator, onboard LED, and it's a reset button also. The second component that is you use that is actually our motor driver that is actually L298 motor driver. So L298 motor driver is a motor driver that actually commonly used for our in robotics and electronics projects of control to DC motors and step up motors. So it operates by using a SP configuration, which allows for the bidirectional motor control that is actually for forward, backward, or stop. And it can be operated using 4.5 volt to 12 volt. Uh, Third component is actually our main component is sensor. We have is a TCR T5000L sensor that is actually infrared sensor commonly used for the detecting the presence or absence of the object, as well as measuring the distance from the robotics and the automation object. It consists of total 7 pins. One is for ground, one is for 5 volt input, and 5 is for output. That is actually connected to our Arduino. Okay, so then we have some minor components like we have used motors like DC motor. At DC motor, we have total used two type of two DC motors. That is usually coupled the gear system to provide the control of the speed and increase the torque. Then we have used the battery for giving our Arduino in the power. So we have used the lithium-ion battery, which is 7.3 volt battery, and we have used the total four combination of four battery that is actually almost 12 volt. Then we have used wheels that is actually total our two wheels for control the car, and one is chassis. So actually the chassis serve the structure framework of our robot, providing the supporter housing the motor, robot, and the sensor components also. And we have used some minor components, so like jumper cable for the car. Jumper cable used to plus establish the electronic connection between the various components like Arduino and the DC motor circuit. And also we have used the battery case for battery case as a house of a lithium ion battery securely and provides a lots of connection. Okay, so the main contribution of me in this part actually do the coding, actually the logical part. So I have done the coding part using C and using C actually, and after the compiling, so I have that used in our Arduino. Okay, so it can control the car actually properly. So I would like to invite my next team member to talk about the circuit diagram of our project.
Good morning, sir. I'm Mohammed Sheikh. The last four digit of my ID is 1879. Now I'm going to talk about the circuit diagram part of our presentation. Here we can see the circuit diagram featuring an Arduino Uno connected to an L298 and motor driver, two DC motors, an IR sensor module, and a power source. The Arduino Uno acts as the main controller of the circuit. The IR sensor module connected to the Arduino for input signal. The L298 and motor driver intermediates between the Arduino Uno and the DC motors. It also controls the speed and direction of the motors based on the signal received from the Arduino Uno DC motor. Two DC motors are connected to the output of the motor driver. For power source, we use a 3.7 to 4 volt battery to power the motor driver and indirectly the motors. In the left side, we see a flow diagram. Here we the first point is sensor input. First, the IR sensor detects the line or track by distinctive light distinctive between light and dark surfaces. Secondly, the Arduino processes the signal from the IR sensor and it decides the motor uh, control logic based on the input. If the line is directed to the left or right of the robot, it adjusts accordingly. Next, motor control. The processed logic from the Arduino is sent to the L298 motor driver, which controls the speed and direction of the motor. Lastly, movement and the line following. The DC motors move the robot forward, left, or right to follow the directed line, maintaining its trajectory on the path. My contribution for the project are designing the electronic circuit required for the line follower robot, also selecting the components like IR sensors, motor driver ICs like 298 and DC motors, and the power supply unit. Uh, uh, I also helped for verifying the feasibility of the design by simulating the circuit in software to ensure the components work as expected. And now I would like to invite Fahim Hasan to continue the rest part of the presentation. Thank you, sir.
Assalamu alaikum, sir. Myself, Muhammad Fahim Hasan. My student last 4 digit 1856. Now I will talk about limitations. Limited environment adaptability. Line follower robots are designed to operate in a specific environment where the line is clearly visible and conditions are controlled. Sense such as uneven surface, poor lighting, or reflecting materials can disrupt their ability to follow the accurately. Sensitivity to interface. The robot relies on sensors, usually infrared sensors, to detect the line. External factors like ambient light, dust, or other obstacles can interface with sensor readings. Limited intelligence and decision making. Line follower robots operate based on programmed logic and simple algorithm. They cannot make complex decision or adapt to unexpected situations such as obstacles, blocking path, or missing sections of the line. Dependency on line quality. The robot performance heavily depends on the quality of the line it is following. If the line is faded, broken, or inconsistent in width or color, the sensors may fail to detect it, leading to incorrect navigation. Limited speed and agility. Line follower robots are generally designed for accuracy over speed. Increasing speed can make it harder for the robot to detect the line and respond quickly, especially during sharp turns. The limits their use in applications requiring agility or high speed. Next slide. Now I will talk about future upgrade. Advanced navigation algorithm. Implementing more sophisticated algorithm like PID control can improve navigation precision, enable smoother movement, and better line tracking even at higher speed. Multi-sensor integration. Combining multiple sensor, IR, ultrasonic cameras, LIDAR, etc. allows the robot is detect lines, avoid obstacles, and adapt to changing environmental condition more effectively. Handle complex tracks. Upgrade can include the ability to navigate complex tracks with sharp turns, intersection, and uneven surface. This involves better sensor feedback and real-time decision-making logic. Integrating ML for path prediction. Using machine learning, ML enables the robot to predict the path based on historical data and patterns. This improves its ability to adapt to missing lines, disruption on non-standard paths. Here is the video demonstration of our project. No. My contribution to the project was preparing the documentation and final report. I compiled all the details, including the design process, testing results, and challenges faced, to create a comprehensive report for the project. Thank you.